it recorded already? Yes. Okay. Let me, okay. So, okay, I think we can start with, because we want to somehow look into the examples of similar midterm, the examples of probably your midterm. This is like tutorial before your midterm. Okay, so I'll just go through a few questions. Okay, so I label them as set A, B, and so on. Okay, so I will just keep explaining until someone asks me question. Okay, so this is not really one-way communication. If you have any issues or question, please let me know. Okay, so normally for your quiz, for your midterms or any types of exam, uh, the first question will be somehow simple question or easy question. Okay, so if you can see here for the first set, question 1 is like defining the term, and then basically it's a very straightforward question and it's very easy. Okay, and the answer normally are very short. And then question 2 is slightly what we call medium level. Question 3 could be like something that needs for your thinking. Okay, so you will also see something like this in your midterm. You're gonna be seeing three questions. Remember, you only have 3 questions. First is simple. So simples means defining the terms or true and false. Second, something straightforward, medium level. Third, slightly hard. And maybe if let's say you have the fourth one, the fourth will be what we call hard. Okay, so let's look at the first question. Define the following item or the terms. Okay, so defining, you may have like the range of marks is 0.5 to 1.5. Multivariate regression. So this is something straightforward. What is multivariate regression? You have regression that has more than one independent variable. You can also have single regression, which is one independent. Okay. In this extrapolation, extrapolation is, okay, I think you have seen this in your quiz as well. This is the estimations of your data outside the range. Normally you need it when you are facing with missing data. Okay, so it is very common for your data in time series. When you have something missing, you don't want to have missing data in certain years. So what you did, you extrapolate, or perhaps you interpolate, depending on the purpose of your study. Okay. So you can also do extrapolation and interpolation in cross-section, but normally in cross-section, if you don't have sufficient data, you can just simply add more variable, add more number of sample. Okay, you normally need this in the case of time series or panel data. Okay, interaction term. You have learned this, right? It's just that like this is like your independent variable in your regression equation that is a multiples of 2 or more other independent variable. So this is just like the definition given by the textbook, but basically interaction term is just that you have 2 or more variables that interact with each other. Okay, so normally in your equation, let me just write it in your equation. For example, y equals to beta naught plus beta 1. For example, this is x1. You have beta 2, x2. For example, you only have 2 independent, and then plus epsilon. Okay, so this is normal equation. But when you have interaction term, means that perhaps x1 and x2 are interacted with each other. Okay, so the equation may look like beta 1 x1 plus beta 2 x2 plus you have another one beta 3, which is x1 multiplied with x2. You can also have 3 different variables, x1 multiplied with x2 with x3. But normally interaction term, the common one is just interactions of 2 variables. You can also have more, but the common is 2. This is like the cross product. Remember, you just learned about cross product. Okay. So next, sensitivity analysis. So why do you need sensitivity analysis? Because you want to test your result. For example, when you run your equation, your estimation, of course, the textbook will give its own definition. Okay, it says that running a number of alternative specification to determine whether particular result are robust or not robust. So sensitivity analysis is meant to test your result. For example, we are talking about this equation. You already estimated the result. You got one hat, a y hat, all this hat, right? Okay. And then now become small e. Okay. So you have estimated it. You got the result. But then you want to check whether your result are robust or not. You want to check whether your result can be generalized to all condition or situation. Then you will run what we call sensitivity analysis. You will run another test. So another test is like just to check your result, right? So it could be instead of your y here, for example, y is the gross sales of mama restaurant. Okay, so this could be the sales of the restaurants, gross sale. Or maybe if you want to conduct the sensitivity analysis, you can maybe check the profit of the restaurant. Instead of the gross sale, maybe the profit. Okay, you may test different independent variable if you want to check the robustness. We can also call it robustness test. The same thing. Sensitivity analysis and robustness test are the same thing. So when you look at the word define robustness test. So basically the question is asking about sensitivity analysis. Okay. So you have the same dependent variable, but you are using different uh, variable, but they are measuring the same thing. Okay. Or you may also use, for example, x1 here. Okay. Instead of maybe x1 is the price of the food, because we are talking about mama sales, right? Maybe something similar to the price. Okay. So if you want to test the robustness, basically you just change the dependent into a different one but measuring the same thing, or you change the independent but you just change the independent in terms of the measurement. Instead of the price you measure in terms of ringgit, maybe you are measuring the price in terms of what else other than ringgit. I think price is very straightforward, or maybe in terms of, I don't know, I don't think we are measuring price in terms of unit. But for example, like distance can be measured in terms of kilometer, in terms of mile. So some variable can have different measurement. So in that case, you can actually test this robustness. Okay, but price is very straightforward somehow, right? Okay. For example, what else? The beef, you can measure in terms of kg, in terms of pounds, in terms of different measurement. Okay. So that is sensitivity analysis. If I'm going too fast, let me know. So I will keep moving. So question 2, this is medium level. Okay. But medium level, it is straightforward. Okay. Suppose your family wants to buy a house, but you think the owner is asking too much of your money. The owner argues that the house worth around 500,000 because of its proximity to Putrajaya Mosque, which is a tourist attraction. Well, many people go to Putrajaya because it is designed nicely, so it's kind of considered as tourist attraction. So that's why houses in Putrajaya are somehow slightly expensive compared to houses in different locations. So as a student of econometrics, you decide to collect data on all local houses that have been sold in recent weeks and create your regression model of the sales prices. Okay. Um, so below are the steps of the regression analysis. Remember, when you want to do your regression, you have a few steps. Okay. Step 1. So this is very straightforward. You want to you review your literature. Okay. Let me approve this first. Okay. How to approve? Okay. So step one, you want to review literature, right? Why do you review literature? Because you want to know what the theory says about this equation. What are the independent or dependent variables? Okay, so step one, in reviewing literature and developing theoretical model, what would you do if? So they come up with the scenario and you have to figure out how to solve it. What would you do if the variable, which is proximity to Putrajaya Mosque, is not specified by the literature? Okay, so let me okay. So now basically what are your dependent? Okay, because you want to know what are the independent variable. So let's see here. So you want to create a regression models of sale prices of house as a functions of a few independent variable. So uh, the price of the house or sales price is a functions of a few things. So let me just write it here. Let me use different color. Okay. So the price of the house is a functions of a few variable. Okay. So what will determine the price of the house? Anyone? I'm not the one who is solving everything. What determine the price of the house? Can someone tell me? Give me your suggestion. Quick. If you want to cover many questions, you better answer it quickly. What will affect the price of the house? We have learned this in class. What determine the price of the house?
Location?
Is it place
Place.
or location?
Okay. Place or location. Locations of the house. Not so clear. What do you mean by locations of the house?
Besides a beach.
What? I cannot hear your voice. Huh?
If it's near a beach, madam.
Okay. So near the beach, that's right. Okay. That is actually other what we call characteristics. Okay, I will touch on that. Other than that, other
Type
than
of house.
types of the house. Okay, that's good. Okay, so basically you haven't done this theory, it's fine, but uh, price of the house. House is just like item. Okay, I can change the house. Instead of house, I can touch on the price of handphone, price of iPhone, price of car, price of any items, right? So house is just what we call a product. So the price of product depends on what? Of course, the first thing is the characteristics of the product. Okay, so um, so I can say here instead of the theory says structural characteristic of the house, but I can put here characteristics of the product. Okay, characteristic could be the types of the house, right? Is it bungalow? Is it a terrace? Is it whatever, right? What else? What is the characteristics of the house? The size of the house. What else? The materials the house is built. Okay, what else? What is the characteristics of the house? The tile, the floor, everything, right? Okay, and then you can also have uh, in the theory they call it neighborhood characteristics. Okay, but this is like the location that you said. Okay, let me just put here. Although the theory says neighborhood, but you may get it confused. So location can be facilities. For example, if the house is located near town or near city, if the house is located what else? Close to the bank, because people want to go to bank, right? If the house is located to the recreational area, okay, and you also have environmental characteristics of the house. Well, this is what your friend says. Like if let's say the house is located near the beach, near something nice. So let me put here environmental characteristics. Okay. So basically the theory says nothing to do with proximity to Putrajaya Mosque, because Putrajaya Mosque is very what we call a special case for the house in Putrajaya, right? But then okay, it says that what would you do if the variable proximity to Putrajaya Mosque is not specified by the literature, but you believe it could be one of the relevant variable in your equation? Because Putrajaya, proximity to Putrajaya Mosque means that this is close to, it's not really facilities. Facilities give you something benefit, right? Like city, but this is like tourist attraction. So what will you do? Will you just simply omit this variable? Okay, so normally if let's say the variable, any variable which is very what we call the specific example of certain model or certain area. So if let's say it is not specified by the model, you have to do a market survey. You have to ask the relevant authority or parties like house seller, the agent who sell the house. They will know whether proximity nearest to Putrajaya Mosque will have positive impact on the house price. Okay, and you can also find a variable that has similar impact. For example, theory says that when your house is close to the tourist attraction place, it will have a positive impact. Okay, you can do two. First, you can ask the agent, those who are working in the area, or you can just find similar variable that has the similar impact. Okay. So as I mentioned to you last time, um, when I did a study on the house price, when I somehow interviewed the house agent, they mentioned to me, well, house close to the mosque. Mosque is not facilities, okay? Because some people don't like it, especially non-Muslim, because it will give sounds 5 times a day. So I asked them, they tell me that, okay, you have to consider the impacts of mosque. So I was like thinking, mosque, it is not even mentioned in literature, but because of because it is relevant in our case in Malaysia, we have many mosques. So I do include mosques as one of the relevant variable in our model, in the model in the case of Malaysia. Okay. So step 2, while specifying your model, what will you consider? Okay, remember step 2, specify your model. What will you consider? You have to include independent variable and how you measure them. Not just include independent variable and you don't know how to measure because you want to estimate your model, right? You have to know the functional form. Is it lean? Is it log? Lean log, whatever, right? And then you have to have the additive error term. Don't forget your error term. This is your lifesaver. If you don't have this, basically your model will face misspecification error because your error term will not capture whatever mistake you have done. Okay. So you can see that the mark is 1.5. Each of them were 0.5. So next step, what is the next steps once you have specified your model? So basically the question is very straightforward. You just answer like it is a short answer. But trust me, when you are exposed with this question, you are giving me an SPM essay. The mark is just small. If the mark is uh, little, so your answer is very straightforward. Should be not so much. The next step, you have to hypothesize expected signs of your coefficient. Then step 4. Okay, in this step, you have collected your data from the Google form, of course, right? You are using the survey, so you get it from Google form. What will you do next? When you get your data, at the moment, many of you have, this is like what you are going to do for your assignment. You have received your data. So what's next? Don't simply run and estimate your result. I know that you have your e-views. You have to inspect and clean your data. What is inspect? Check your data. Make sure that you don't have outliers. If you have outliers, you have to drop it perhaps. Or maybe you have the missing data and then you have to figure out what you have to do with the missing data. Sometimes the missing data is not so uh, important, so you can maintain the data. But sometimes the missing data is something that you really think it is important, like your relevant variable. So maybe you have to drop the observation. Okay, this is step 4. once you are okay with the data that you have, okay, step 5, what will you do? Of course you will estimate your data. Okay, but here they will ask you the problem. While doing the estimation and evaluations of your equation, you found that the estimated equation does not fit your data. Means that you discovered many problems. When you estimated it, somehow it doesn't follow your expected sign. All the independent variable are not significant. Even though they are significant, somehow they don't they don't really follow your expectation. Means that your estimation just going into disaster. It doesn't really follow your expected sign. It doesn't really what you have expected. So if let's say you have problem, for example, you run the equation, you got the multi-core issue, you have uh, misspecification problem, you have hetero, you have serial core, all the problem. Basically, you are violating all the classical assumption. So what will you do? What's wrong? Data. Okay, if you are facing something like this, so it says that what will you do if this happen? You have to go back to step 1 and fix it. What is step 1? You have to review the literature. Does your equation, your independent and dependent, how do you measure it? Does it really follow the literature? You have to really check it again. Okay, that's why step 1 is very important. Some people just simply ignore it. Okay. Okay, so I'll go next. So step 6, you will document your result. So it says that in documenting the result, what are the information that you would like to present? Okay, remember when we look at the slide, they already give you the estimated one. Okay, so you want to see of course, the estimated coefficient, and then below the coefficient, you have standard error in parentheses, right? After the standard error in parentheses, you will see this t value, and then you will also see the r square, and then to be more accurate, you want to see r bar square. What else? You also want to see the n, the total of observation. If let's say you are talking about time series data, you may want to report the B. Watson test as well. Okay, these are some of the information that you want to present so that uh, people know how to read your result. Okay, so the mark is 1.5. So don't just give me one information. Oh, you will present coefficient. Not really. So coefficient will give you 0.5. So 1.5, it means that you have to give at least 3 information. 3. If you give 1, means that you will get 0.5 marks. But if let's say you give more, of course you will get full marks. Okay, so you have to know how to write your answer depending on the marks. Okay, so next, remember, you only have 3 questions, but then they may have their what we call they may have the kids with the grandkids as well. Okay. So next question, omitted variable bias. What is known to cause this bias? Okay, you know that, right? This bias is caused because you omit the relevant variable. So the textbook says that this bias caused by leaving a variable out of an equation. Okay, basically omitted variable bias means this is the bias caused by relevant variable that you omit from the equation. So the bias could be positive, negative, depending on the variable that you have omitted. Okay, are unbiased estimated always better than the biased one? Okay, you want the unbiased, of course, but does it mean unbiased always better than the biased? Why or why not? Of course, not necessarily. You need unbiased, of course. What do we mean by unbiased? Let me draw it here. I don't like red color. Okay. If you want to draw your diagram, unbiased means your estimation, you estimate the true beta. You successfully estimated the true beta. Means that who is this? Okay. So unbiased means this is your estimation. The true beta is in the middle, and then your estimated beta is the same as true beta. That is unbiased. But if let's say your estimation is unbiased, it's good. But then what happened is that you have what we call high variance. Okay, so you don't want to have high variance. Means that your diagram is flatter. So your sigma here perhaps 10. Okay, yeah, the first one, the sigma is okay, I think maybe it's better to draw different graph so that you can see clearly. Um, okay. So you have two conditions here. The first one is this one. This is the this is the true beta, right? And then this is your estimation. Okay. So this is what you call unbiased. Unbiased means your estimated beta is the same with the true beta. Of course, you like it, but it doesn't mean that unbiased is better than the biased one, because sometimes you also have the biased one. Okay, bias means, okay, let me draw it here. Okay, so the true beta is here, but then somehow your estimated beta, okay, you estimated the beta to be here. This is your estimated beta. It is biased, right? Okay, you estimated it to be here, but in terms of the variance, because it's very narrow, the variance could be, for example, this is 2. The unbiased one, because it's a bit flatter, the variance could be maybe 10. So in terms of unbiased, of course, it's good that you are able to estimate the true beta. But in terms of the variance, the second one is better because the variance is actually smaller. Okay, so that's why it says that where is it? Unbiased estimates always better than biased. Of course, you want unbiased, but it doesn't necessarily means that it's always better, because you also want your estimation to be less variance. The sigma should be smaller. Okay, so so you should be explained that way. Okay, what's the best solution to avoid this bias? What bias is that? Omitted variable bias. If let's say you omit the relevant variable, the solution is add the omitted one to your equation. Simple. So normally the second question, very straightforward. Okay, the mark is also not so much. So what is the problem associated with the suggested solution? You already use, your solution is adding the omitted one, but what's the problem? Omitted variable bias, normally it is hard to detect. Sometimes you don't even know the variable is omitted. If you know that the variable is relevant, you will put it in the equation. But the fact that you didn't put it in the equation, it means that you don't even know that is the relevant variable. That's why you omitted it, right? So what's the problem with this omitted one? You don't know that that is the relevant variable. And sometimes choosing the variable also difficult. You don't know which variables should be added into your equation, right? That is the problem of omitted. It's easy to suggest the solution, add it back, but what to add into your equation? Okay. What are the criteria for determining whether a given variable belongs in the equation? So criteria to choose whether you want to add or drop the variable. Remember, you have 4 criteria. You have to check the theory. Is the variable that you want to add or drop supported by the theory? You have to check your t-test, t-score, whether the variable that you want to add or drop has a significant t-value, only that particular variable, not the other variable, okay? Then, does the overall fit of the equation improve? So basically, number 3, you want to check the R square, okay? And number 4, bias. When you add the variable or you drop the variable, does it introduce any bias to the remaining variable? Okay, these are the criteria that you will have to consider if you want to add or drop the variable. The same thing with the functional form. Okay, you have to think about all these 4 things. Okay, so finish with the medium level of question. Okay, it's very straightforward. So let's move to the next one. Okay. If you have question, let me know, okay? Because I cannot see your face. I'm just checking. I'm just looking at my screen. Okay. Question, the next one. To determine whether going to class improves students' academic performance, Dr. Nabila, a student's academic advisor, developed the following equation. Now I think we should change. Instead of Dr. Nabila, we have Dr. What? Who is your AA just now?
Dr. Sakina.
Yes, Dr. Sakina. We will change Dr. Sakina, right? So you have this equation. Okay, G is what? The grades of I student in Dr. Nabila's class. Okay, so there are many ways on how to analyze students' performance, right? In IUM, normally we wanna measure student performance in terms of CGPA, isn't it? We are using CGPA. Okay, but we can also have the grades. Okay, ATT is okay. The student's grade is the functions of the percent of class lecture that I student attend. So basically, this is your attendance. Of course, you are taking attendance, right? And PS, what is PS? Percent of the problem set that the students completed. Means that the exercise that you are doing, does it has and some impacts on your performance, academic performance. Okay. So for me, I think the independent variable seems okay. Let's just continue. Suppose that Nabila estimated, let's change. Suppose that Sakina estimated the following equation. Do the estimated result agree with your expectation? Means that your sign, does it follow your expected sign? And explain your reasoning. You see 3 marks. So you really have to explain because you have 2 independent variable. Okay. So basically, you will see the result. Both are positive. The more you attend in class, the more you attend the lecture, the more your understanding will be. So maybe it will have a positive impact on your CGPA, on your grades. And what is the PS just now? The exercise or problem set that you have completed will also have some impact, positive impact. So basically, you can say yes. Both variable has a positive impact. It follows your expected sign. So you have to just justify. Okay, as I mentioned just now. Okay, what's the real world meanings of having r square equals to 0.33? So there are many ways on asking, interpret your r square. Okay, sometimes when you look at it, the real world meanings of having r square, they can just say, okay, interpret r square equals to 0.33. Okay, as long as the question is something like this, they just want you to interpret your r square. R square is 0.33. Does 0.33 seems high, low, or just about right? Okay, so if you want to know whether, okay, we will answer the second question later. So let's just interpret the R square. R square is just measuring the goodness of fit, right? Whether your independent variables are able to explain the change in your dependent variable. Okay, so if you look at the answer from the textbook, you can give different ways of answering. R square of 3.33 means a third of the variations of students' grade around their mean can be explained by these 2 variables. Or you can just say this model, or you can say this model, or you can say what is attitude just now? Attending a percent of class lecture. Then okay, attendance. Okay, maybe I just put attendance. You can say attendance and completions of problem set are able to explain the change in students' grade by 33%. Okay, that is the simplest way of explaining. Means that your model, your 2 independent variables are able to explain the change in your y or in your dependent variable by 33%. That's it. Okay. So somehow you don't really have to memorize the answer. Okay, if you don't understand the answer, you just memorize it. It doesn't really help because we can always change the question. The most important thing is that you have to understand how to answer the question. That's why I will give you different ways of answering it. Okay? Okay, next question. Does this number high, low, or just about right? Okay, so if you want to answer this question, you have to check. Is it cross-sectional data? Is it time series? Okay, because I will not touch on the panel because we never learn panel. Okay, so you have to check. This is about, okay, you can see this is I, right? So individual data. So this is cross-section. Cross-section is about different people. Different people have different behavior. There is no way for you to be able to explain 100% of people behavior. Of course, right? No one can do that. Okay, so 33% being able to explain people behavior is somehow actually high. In fact, if you can say you are able to explain 20% of people behavior, that's good enough. Okay, but if this is M series, of course, this is too bad. Okay, so let's look at how the question, the textbook give you the answer. This might seem low to beginner, okay, but it's about right, or perhaps this is actually high if you are talking about people behavior. Okay, 20% for cross section is good already. Okay, is it reasonable to think that only class attendance and problem sets completion affect your grades in class? Explain your reasoning. So this question want to tell you, do you have other irrelevant variable? No. Do you have other relevant variable that you accidentally omitted from your equation? Is there anything that you think can affect your grade? The change in your grade? Okay, the change in your CGPA. Of course, there are a lot, right? So mostly the question that are asked to you is something close to you. We will not ask you something which is not relevant, something that you cannot think of. It should be related to the students. It should be something that you can rationalize. Okay, what affect your CGPA? A lot, right? Okay, so if you look at the answer, the most likely variable to add in this equation is your GPA or some other measure of student ability. So normally the textbook will give you something general, but you know better what affect your CGPA. It could be, I don't know, parents influence. Perhaps if let's say your parents are very particular about your grades, of course you will work hard. Or maybe you have the right friends who always study hard and then invite you for uh, group discussion, whatever. Maybe that will also affect you. What else do you think that can affect your CGPA? Anyone? It is student CGPA. It's not my CGPA. So what could affect your CGPA? Anyone? Can you tell me? Because I also don't know. Hmm. What is it?
Can you like go up a bit so we can see the previous variable?
What is it?
Can you like go up a bit so we can see the previous variable?
The previous variable. The previous variable is just your uh, attendance and problem set that you have completed. Only two. No more that can affect your CGPA?
A few more.
What is it? At least you have to give one.
Gender.
Gender affect your CGPA?
Yes. So I don't
How?
know the assumption. So the boys will always like they so expected them to have a low GPA, and the sisters are always concentrating doing all
That's
the work.
um hmm. Well, normally the reasons you may have gender in your equation, but to say that boys is inferior compared to girls, that's a very strong what we call strong argument. Okay, that you have normally all these demographic variable will be put in your equation because we just want to see different demographic will have different impact. That's it. But specifically, sisters will have more better result the theory doesn't say that. Okay, there is no way that because you are female you perform better. It could be because they are maybe hardworking. Mm, but to suggest a variable, you shouldn't really simply just take the demographic. Demographic is meant to just to check whether there is a differences in terms of different demographic. You
Household
have,
income?
huh?
Household income?
Household income. What will be your justification?
So some students, they are self-sponsored and everything that they have to. Some students they have to do part time. Some students they have money from the parents, so they have more time to study.
Part time is another variable, right? So okay, I can see two things. So household income, you can see the incomes of the parents. If let's say the student's parents has high income, perhaps the income can be used to send the students for tuition. So when the students attend the tuition, extra classes, which is paid, maybe the students will understand better. Okay, because of the income, he has the capability to attend more classes. He has the capability to hire tutor, so he will understand better and that will have a positive impacts on the CGPA. Okay, so you can explain that way. So when you explain the relevance of the variable, you have to make sure that it is making sense, making economically sense. Okay, for example, part-time. You can also, okay, part-time could be another variable that can affect your CGPA. For example, the students are working as a part-time, so they have limited time to study, right? So their time, for example, students have 10 hours for per day to study. So those who are working part-time, maybe they have to split 5 hours for study, another 5 hours for working. Okay, so because they have limited time to study, they don't have suction time, so it affect negatively on their CGPA. So you have to be able to justify rationally why do you think the variable is relevant. Some people just put okay income, that's it. But see, yeah, the question will say explain your reasoning. When you have to explain, means make sure that it is reasonable. Okay, okay, let's continue. I know that you know better. There are many other variables, of course, that can affect your CGPA. Even though you are saying that okay, if you have a boyfriend or girlfriend, that will also affect your CGPA because now you split your time, study and spending with your girlfriend or boyfriend. It will also have some impact. Some impact could be positive or negative depending the influence of that variable. Okay. So what happened to R square and R bar square if you add explanatory variable to the equation? Okay, this is very straightforward, right? When you add more variable, you expect both of them will increase. Okay. Can we conclude that the larger the estimated coefficient, this is your beta, the more important the variable justify. Okay, so let me go back to the equation. So you can see here when you estimate, when Dr. Sakina estimated this equation, so attendance has a larger estimation, larger estimated coefficient, 1.74 compared to 0.60. So can you say that attendance is actually more, where is it, more important than the second one? Okay, this is what the question is asking. Okay, so basically your coefficient doesn't show doesn't show importance of the variable. Okay, so the answer is since the units of variable are actually different. Okay, attendance is measuring how many times you come to the class. This one is how many questions you have completed, you attempted to solve. So they are measuring two different things. That's why when they have their coefficients are measuring different things. So you cannot say the bigger coefficient is more important. No, because they are looking at different things. Okay, unless these two variables are measuring the same thing. When you have one bigger coefficient, then you can say this one is more important. Only if they are measuring the same thing. That's why you put here, if all variables are measured identically the same thing, so indeed the size of coefficient is measuring the importance. But remember, if you are putting the variable who are measuring the same thing, what happened? You are putting the same variable, measuring the same thing in the equation. What happened?
Multicollinearity.
Yeah.
Multicollinear.
Yes, you don't want to put the same variable in the same equation. You will have multico. So what it says is that normally when you have the variable, even though one variable has a bigger coefficient, it doesn't measure importance because they are measuring different things. Okay, there is no way you will put the same variable in one equation, or else you will have multico and you have to drop the variable. Okay, next question 4. So we expect that when you have question 4, question 3 will be not so hard, okay? Because you have to justify somehow, but even though you have to justify, basically you have to use your logic, okay? So question 4 means that you have to think a bit, okay? So let's look at the question. How does it look like? A regression model of the number of cars sold in the US from 1980 to through 2004. When you look at these years, what would you say? What would you think? Are we talking about cross section? No, right? We are talking about a periods of time. This is the examples of time series. Okay. And this is how you want to report your result. Remember the previous question, how do you present your result? I have to pick up this call just for a few, 1 minute. Oh. Ah. Okay. um okay, so this is how you want to present your result. Okay, you have the head. You can see that head means you have estimated the equation, and then you have your, what we call here, constant term, and then you have your variable and your coefficient, and then the number in parentheses is your standard error. Why do you have to put the standard error in the parentheses? Because it says that while you are estimating your equation, this is the error that you are making. That's why it is always in parentheses. And then you want to report your R bar square. You can have R square, but to be accurate, you want to report your R bar square. But some people, they just report 2 R square. This is the result. R bar square, this is also the result. Okay. Because you want to put R bar square or R square to show the goodness of fit of your model. W. Watson. You will see W. Watson when you are talking about time series. If you look at this time series, if you are looking at this W. Watson value, do you spot any problem? Do we have serial core? You forgot about serial correlation already, right? I can tell. Even though I cannot see your face, I can tell. So you want your W. Watson to be around 2, remember? So when it is around 2, means that it is free from serial correlation. W. Watson from 0 to 4. You want it to be around 2, to be free from serial correlation. Okay. So now you also want to report how many observations you have collected. So this is how you want to report your equation. I also expect to see something like this in your assignment. Okay. Don't put all the table generated from eViews, okay, because those are raw data. So if you want to report it in a professional way, this is how you present your data. Okay, where you have to define what is C, what is P, what is Y. Okay, C is what? Thousands of cars sold in year T. Price index for domestic car. Y is disposable income, blah, blah. A, billions of dollars of auto industry advertising expenditure in the R, your interest rate. What do you call this data set? Some people said this is regression. This is multivariate regression. This is just time series, okay? So specify the appropriate null and alternative hypothesis for A. What is A? Your advertisement. So what do you expect? Okay, let me see the equation first, okay? This is the car sold. Okay, the sales of the car. So of course, the sales of the car depends on the price of the car. You expect when the price is high, what happened to the sales of the car? The sales will fall. You are happy with negative sign. Income, disposable income. What is your expected sign? Positive. Waiting for you take ages. Income positive, right? Higher your income, more purchasing power for you to purchase the car. So the sales of the car may increase. Advertisement, you believe that when the company spend or expand, when the company spend on advertising their car, it will increase the sales of their car. So advertisement will have a positive impact on their sales. R is interest rate. Higher interest rate, lower your purchasing power. You don't want to have higher interest rate. So negative. Okay, fine. So we want to see A only, advertisement. So you expect that if let's say they spend more on advertisement, you expect that it will have a positive impact on their sales. Okay. So remember in the final exam, let me just make it general in the exam. You have to have your own expected sign. They will not tell you, well, A, it has a positive impact. No. In the quiz, of course, I will say the impacts of this variable, it reduce whatever, it increase whatever. But in the exam, you have to figure out what will be the impacts of the particular variable. Okay, so this question is also very straightforward. Specify the appropriate null and alternative hypothesis. So just put it there. Interpret A. If this industry advertising expenditure increase, okay, let me see the equation first. A, right? So A is loan. C is just linear. This is lin log. Lin log means when A increase by a lot, C will change by unit, by not so much. Okay? So when you have log here, basically it will be in terms of percentage. Okay, it will increase or change by percentage, depend. Increase because it is positive. But if let's say the sign is negative, it will decrease. Okay, so when you have log here, so A increase by percentage, by a lot. So the change in C by unit, you don't really you don't have the percentage. Means that the C will be divided by 100 by unit. It changed by decreasing rate. Okay, so let's see. You can also read this, but we can say when your advertisement increased by 1%, log, right? The car sold in year T will change. You have to divide by 100. Whatever the value you got here, the value is 6.0. So you have to divide by 100. So you will get 0.06. Unit, comma, don't forget comma. Ceteris paribus. Or you can say a whole other variable constant. If you miss ceteris paribus, instead of getting full mark 2, you will get only 1 marks. Okay, because you don't call the other variable constant. So when the advertisement increase, the rest will also change. Okay, that's why you have to take notes of the other variable. Next, when econometric problem appear to be present in this what? I was reading when. By looking at the time, it's almost 7. That's why I was reading when. Okay. So just let me know when you want to stop the discussion. I will just keep continue. Okay. What econometric problem appear to be present in this equation? Justify your answer. 2. So if you see the mark is 2, you need at least 2 problems. You can see problems with the plural. Okay, but trust me, many just give me 1. Okay. The first thing, as I mentioned to you, when the question asks about problem, you have to figure out what will be the omitted relevant variable. Just figure out only one omitted variable. Okay. If you look at here, the textbook also said omitted competition from foreign made car, because you are talking about domestic. If let's say you have foreign car, of course it will affect your sales. What else? The B Watson is just nice. So you don't have a positive serial correlation. What else can you spot? You have omitted, just find any relevant variable. Remember, you want to give at least 2 problems. What else from this equation? So you have to check, are all these variables are following your expected sign? Somehow you are happy with the sign, right? That's why I check the sign. And then, are they all significant, statistically significant? You have to check. If they are not statistically significant, well, you can say that, oh, maybe because of the omitted bias, right? But you already have mentioned omitted variable. So what else can you spot? The B-Watson is fine. R-bar square, although for what I said, although for time series 85% is actually quite low, you need more. You also can think of maybe a functional form. Okay, you can also think about what else. If you look at the variable, are they all relevant? The price of the car, of course, affect the sales of the car. Income. A is just now advertisement. R, what is R? Interest rate. Do you think all the variables are relevant?
Theoretically.
So maybe you
But-
can think of what? You can think of the functional form. When you talk about time series data, this is a macro data. Macro data normally is a large data. Okay, you may need ln, you may need log for the variable. So normally for macro data, you're gonna have log, or you can have ln log, but you need log. Okay. What else? Okay. At the moment, somehow, the textbook only give 1 problem. But for your case, if you see 2 marks, you have to figure out at least 2 points, two problems. Okay. Because they put S problems. Okay, suppose you were now told that the simple correlation coefficient. So when you have simple correlation coefficient, this is actually testing your serial correlation between P, A, and Y were all between. So the simple correlation coefficient is actually high. They are somehow closely related. Okay, so simple correlation coefficient is to test your serial correlation issue. And that Bruch-Pagan, do you still remember Bruch-Pagan? What do you need it for? Bruch-Pagan test. We just saw it last class.
Heteroscedasticity.
Yes, heteroscedasticity test. But your Bruch-Pagan test was surprisingly low. Okay, so when you compute n multiplied with r, you test the hypothesis. When it is low, when you test the hypothesis, it will not be significant. Instead, you don't reject the H0. When you don't reject the H0, H0 is homo. So you don't reject it, there is no problem of hetero. So it says that, would your answer to part D just now, you mentioned here you have omitted. What else you mentioned? You have what we call functional form, because this is macro data. You want to put log functional form. Okay, would your answer to part D above change? Of course, because previously when you look at W. Watson is about around 2. So when it is around 2, you are saying that no evidence of positive serial correlation. But then, when you are using different tests, which is simple correlation coefficient, the value is high. So it says that you have serial correlation problem as well, but using different method. So would your answer to part D change? Of course, it changed, right? You have, oh no, sorry. Simple correlation coefficient is to test the multi-core, not serial core. Serial core is the way Watson, and one more thing is, I forgot what is another thing for serial core. But simple correlation is actually your multi-core. Okay. Let change. I rephrase. Simple correlation coefficient is to test your multi-core. So basically, these three independent variables are highly correlated. So your answer to part D change because now you found out that you have somehow serious or severe multi-core issue. Okay. I just simply forgot simple correlation. Okay, so we have covered like 4 different level of hardness. Okay, any question? So far so good? So far so good?
Alhamdulillah.
Okay, so you want to stop here? Or you want to have 10 more or 15 more minutes to just go through other question? Or that should be sufficient?
Maybe we need more time.
Let's see the majority. I cannot see your face. All of you are closing your image. So you want to have around for 15 minutes, 20 minutes to see other question, or this should be sufficient? What do you think? Sufficient or not? When you have this online, basically you are not limited to the time. If the class physical, we have to stop once we finish the class, right? Should we have some more?
Do you think there are other questions that you should address to us?
I don't know. Let me just scroll down a bit. So well, normally your question is very what we call generic, very similar. Question 1, something simple, whether it is definitions or true and false. Okay. Something like testing your knowledge. Okay. The simplest one. I don't know. I don't know whether I have to somehow read, explain one by one. I will just scroll down a bit. And question 2, this is also what we call medium level. They will give you like some scenario. So your answer is very straightforward. For example, like this, suppose you would like to investigate whether KNMS students' performance. So this is like your CGPA is affected by. So now they mention to you what will affect your CGPA. Their class attendance, allowance, student allowance, and hour of study. Somehow your CGPA also depends on your hours of study, of course, right? So you can see here, write an appropriate econometric equation to illustrate the above relationship and define the units of measurement of all your variables. So you write performance. How do you define performance? CGPA or GPA. Okay. And details. Okay. Suppose you want to include dummy variable. What will it be? How do you define it? So any relevant dummy will be considered. For example, sleep quality. Okay. I don't know what kind of dummy variable. Maybe whether you have group what we call study in group or not. Okay, so and then you have to define it because those will be affecting your GPA. And then your hypothesis is very important. That's why I mentioned that based on your previous quiz, everyone is making mistake on the hypothesis, so you have to review your hypothesis chapter. Okay, as I have shared the YouTube, look at it. Okay, not so hard. Okay, and then question 3, slightly hard, not so hard. They will give you the equation. Okay, and then they will ask you. Now you have to use your rationale. Explain the relationship between D squared and P. What is P? Sales price. Similar, right? And D squared, D is distance to KLCC. KLCC is like facilities, right? When you go to, this is like city. When you go to the city, there are so many entertainment, many things that you can get it there. So you expect that the closer your house to the KLCC, the more benefit you will get. Of course, the higher the sales price of the house. Okay, so higher the distance, of course, will reduce the house price. Okay, so you have to explain the relationship. You have to justify the rationale of this variable. Okay. As distance from CBD is okay, because KLCC, right? CBD is Central Business District. This is like your city. As distance from city increases, it will reduce the attractiveness of the house, so will reduce the price. But sometimes distance from the facility or from the city can have inverted U shape or U shape. So you have to explain. So do the inclusions of D and D squared, which you have been tested, makes economic sense. So you just have to explain whether D squared is making sense. Because when you have D squared, you will have U shape or inverted U shape. So does it make sense? So it means that you have these two, right? Distance. Okay, let me just draw the diagram. This is the price, this is the distance. Okay, so you can have increase the distance, increase the price, and after a certain point, the higher the distance, the lower the price. Okay, so for example, KLCC, right? We are talking about KLCC. So when this is 0, so when your house 0 here, 0 distance. So when your house in somehow in the KLCC area, well, I can say that you have all the traffic, you have all the noise pollution, sounds pollution, is a very congested. Although the price, I will say the price is not so high unless you have some distance close to KLCC but not around the KLCC. So it says that slightly higher distance from KLCC, the price will be good, will be high. But if you are too far away from the city, too far away from the KLCC, you are far away from the entertainment, far away from the facilities, the price of the house will be lower. So this making sense, right? You can also explain, this is inverted U shape. You can also explain U shape. Okay, so it depends on how you want to explain it. You can say, well, this is 0, right? Well, if let's say the house is somehow close to KLCC, the price is high. But the further the distance, the lower the price. Okay, but after certain point, which is here, why the price is going up? Because now you are saying, this is depending on how you want to justify. Now you are saying that after certain point, this is where you are talking about you are somehow close to the environmental or nature area. So you are close to the waterfall, you are close to the beach area. So the price is getting higher because you are close to the nature. So you can explain this way. It could have inverted U shape, it could have U shape. So depending on your explanation. So you cannot just say that the price and distance are inverted U shape or the price and distance are U shape. You have to justify it. Okay. Do you appear to have any irrelevant or omitted variable? Explain. So they already mentioned, do you have something on the irrelevant? So you have to check, based on this, is there any irrelevant variable you think? A number of bedroom. I remember when you talk about house, the characteristic of the house will determine the price of the house. The more bedroom, of course, the higher the price. Distance is the facility. Age of the house, the older the age of the house, the lower the price, you need a new house. Number of car parks, this is like the characteristic of the house. When you have more uh, parking, of course the price will be high. The dummy variable, so somehow this is the characteristic of the house. Whether the house is freehold or leasehold, they put it zero otherwise. So normally when the house is freehold, you know what is freehold? Means that when you purchase the house, you have the ownership totally to yourself. So the freehold house is of course more expensive than the leasehold. Leasehold is that when you purchase the house, you have the ownership up to, for example, 99 years. This is very common in Malaysia, especially when your house is close to the city area. Okay, because the government think that after a certain point, they may want to develop the area, so they don't want you to stay there forever. Okay, that's why they put it leasehold. Mm. Okay, so all this seems relevant to me. So, other than where is it? Do you have any irrelevant? Of course, you always have irrelevant. Irrelevant, no irrelevant. But do you have any omitted? You always have to figure out the omitted one. Okay? No irrelevant, justify all the variable. Omitted, just figure out any omitted variable. For example, type of the house, materials of the house, size of the house. There are many variables that can affect the house price. Consequences of irrelevant and omitted variable. Okay, so you just basically, second question will be straightforward, but then you have to justify. Okay, and then you will also see hypothesis testing. Okay, for this case, remember your distance could be increased or decreased. It has squared, right? It may have U shape or inverted U shape. So there are two ways because you are not sure the signs of the variable. The question doesn't tell you are not sure, but you have to figure out. Okay, for the distance, will it have a positive impact or it could also have negative impact because you are not sure. To tell. Then you test. Okay, and then the same thing here. This expert says that freehold or leasehold is irrelevant, or maybe they want to drop one variable or they want to include another variable. So what you gonna do? Remember, if you want to add or drop the variable, you have to consult with these 4 specification criteria. Okay, so you mentioned Jerry. Jerry said theoretically sound. Don't drop. So you don't just put 1/2, 1/4, 1. So 0. So you have to mention, if let's say it says that theoretically supported, what should you do? Don't drop. Okay. T-test, significant, don't drop. Okay. Oh, this is drop because R square doesn't improve or whatever. Okay. So you have to consult the specification, for specification and tell your decision. Because here you have 2/4, you can maintain or drop depending on your stand, whatever you want to argue. Question 4, very similar, slightly hard, not so hard, but you have to figure out. Basically, this is where you will be asked on the econometric problem, like multi-core problem, serial core, hetero, maybe yeah, these 3 things, the last 3 chapters. Okay. So you can see serial core. What else? Econometric problem you have to figure out. So these are all about the last question. Remedy, how do you spot the problem? How do you identify it? Something like this. Okay. So I think you can see the patterns of the question, right? They are very similar. Any question? And if we keep, I think we have covered everything. You can see the patterns are the same.
Amida, I have question.
Yeah.
Regarding if the question asks for the omitted variable, and then we expect even the omitted variable that we expect have the multi-core issue, and then we mention like some variable that we think, and then lastly we mention but this omitted variable may have multi-core issue. Is it still correct answer or wrong answer?
If you want to come up with omitted means relevant variable that has been omitted. So relevant variable shouldn't have multi-core issue. So you have to figure out the omitted that is not having multi-core, because multi-core is similar variable. You don't want to come up with similar variable. Okay?
Okay.
Anything else?
What about the sign of the omitted variable? Is it okay to choose any positive or negative?
The signs of omitted variable depends on the theory. So you expect whether the variable is positive, it has positive impact on the dependent. So it depends on the theory, depends on the expectation, your expectation.
Okay, madam, thank you.
Okay, anyone else to ask? Let me just stop the recording so that you will not listen too much. Okay, stop recording.